Welcome to IOQM 2025 Region 4 and 5 solutions. Okay, so in this is the part 4 of the video. In this video, I am going to cover questions 26 to 30. All are 5 marks questions, and these are the real tough questions of the Region 4 and 5 paper. Okay, so out of all this, also the 30th question is really tough. If you have solved it without previous knowledge, you are really a math genius. You will sit in the team for representing India. Okay, exactly a similar tough question has come in the first paper also in 2025. So I think you can take it for granted. Mostly every paper from now onwards will get 1 or 2 very tough questions which will decide who will be sitting in the final team. Okay, yeah, let's get into the 26 to 30 problems. Okay, all are 5 marks questions. Let ABC be a triangle. DB is the midpoint of side BC, O is the circumcenter, and H is the orthocenter. If triangle ODH is equilateral with the side length equal to 6, and the area of the triangle ABC can be written as small a square root of small b, where AB are positive integers in the minimal form, then what is the value of a plus b? Basically, we need to find out the area of triangle ABC. Okay, and what is given is, first thing is, yeah, most important thing, you have to draw the right picture. This diagram also not so easy actually. Yeah, so there is a triangle ABC here. Okay, and you have a circumcenter O. Okay, and the midpoint of the BC is D. Okay, now H is the orthocenter. Now ODH is a equilateral triangle. That's what is given of side length 6. Okay, now one thing you understand, what is OD? OD will be perpendicular to BC because O is the circumcenter, D is the midpoint, and how circumcenter is formed? By the perpendicular bisector of the sides, which means a line will actually go from here only perpendicular to OD will be perpendicular to BC, only then it is possible, right? So understand, OD is perpendicular to BC. And what is H? H is the orthocenter, which means if you draw a line from AH, it will cut BC at E. This is nothing but orthogonal or height of this triangle actually. This is the orthogonal projection. Okay, perpendicular line from A to BC. So AE also perpendicular to BC, OD also perpendicular to BC. Okay, this is one thing you should understand very well. Okay, once you know this, just for important information I'm giving, if you have a orthocenter, if you have a orthocenter and a circumcenter, and a line is drawn on the median, then this is where G actually centroid is formed. Okay, so centroid is on the same line as orthocenter and circumcenter. Okay, so and obviously centroid is formed by the median, so this will be the G. Okay, anyway, this is just for information. There is no importance of G here. Okay, so for to solve this problem, you need to know 2 very important triangular formulas. Okay, very important. Without that, I think it is very difficult to solve this problem. Okay, so let's see. We'll come to these points. These are the things we'll derive. Okay, this AH, all this will derive. So we'll come to this one anyway. So let's see how to come to this point at least. Okay, so OA equal to OB equal to OC. We know that because this is circumcenter, which is equal to R, circumradius. Okay, now this is one important triangle rule you should remember. OD is equal to R cos A. Okay, this is the very important thing you should remember. And also another important thing is AH equal to 2 times R cos A. That means 2 times OD. Okay, AH will be 2 times OD. This you should know. Okay, once you know this problem is moderately easy actually. Okay, I don't say it's easy. Okay, AH equal to 2R cos A, which is nothing but 2 times OD, that is 12. Okay, because OD is given as 6, right? This is the equilateral triangle with side 6. Okay, now so we got one thing AH, which is 12. Okay, now we'll get other things one by one. In triangle DHE, okay, DHE, this is right angle, we know at E it is right angle, and this angle is 60 degrees, and this total is right angle, correct? OD is perpendicular to BC, so this is right angle, and angle ODH is 60 degrees because this is equilateral triangle. So HDE, angle HDE is 30 degrees. Okay, now what is sine 30 here now? Okay, sine 30 is nothing but HE opposite by hypotenuse HD. HE by HD. So HE is equal to HD sine 30. HE equal to HD sine 30, which is nothing but 3. Now you got HE also, you got AH also. So obviously AE equal to 15. This is the height of the triangle. Now you got the height. You just need base, that is BC. If you get, you're done. You get the area. Okay. Now let us assume D is, now you have to solve this problem using coordinate geometry. Okay, so D is your origin. Okay, not O, please. D is origin. So BC is your x-axis. Okay, OD is y-axis. Okay, so if D is origin, O is nothing but 0, comma 6, because we know OD is 6. Correct. And then what is H? H also you can easily find out. This is actually this is 3, this is 12. Okay, so ED also you can find from this right angle triangle if you want. Okay, ED is also you can find, which is nothing but 6 square root of 6 square minus 3 square. Okay, that is 20 square root of 27, 3 root 3. Okay, otherwise how can you find this? You can just call H as m comma n. Okay, and you get two equations. One is OD, right? OD is HD is nothing but m square plus n square, which is equal to 36. Okay, because this is 6, HD is 6, so it will be square of 6 square, right? Okay, and OH, from OH you get m square plus n minus 6 whole square, which is 36. You can solve m comma n, you will get minus 3 root 3 comma 3. Otherwise, you can find out ED easily from this right angle triangle, which is 3 root 3. So E is obviously should be minus 3 root 3 because it is on the left side of the origin. Okay, minus 3 root 3. And we know H is 3, height is 3. So this will be the y coordinate will be 3. Okay, so now you got, these are the values we got. Okay, we can also actually say A is nothing but minus 3 root 3 comma 15, right? Minus 3 root 3 comma 15. That is also straightforward. Now once you know these values, okay, minus 3 root 3 comma 15, right? Okay, so I think we don't need to do this. We also already know A value. Okay, now OA square is nothing but radius circumradius R square, which is nothing but, this is O is 0 comma 6, this is minus 3 root 3 comma 15. So if you apply Pythagoras theorem here, it will be 27 plus 81, which is equal to R square equal to 108. Okay, R square is 108. Now that means R is, you have some value for R. Okay, now let's say B and C are nothing but minus C comma 0 and C comma 0, because they are on the x-axis. Okay, now you take OB square equal to, okay, OB square also R square, correct? OB also R square, which is nothing but C square plus 6 square, which is R square. So C square equal to 72, or C is plus or minus 6 root 2. So this will be minus 6 root 2 comma 0. This is 6 root 2 comma 0, right? Because this is on the right side, this is on the left side. That's it. And D is the midpoint of this B and C anyway. Okay, so you have your B, you have your C. So BC is nothing but 12 root 2. Now you have all the values which is required to calculate the area of the triangle. So area of the triangle is nothing but half into AE into BC, which is 90 square root of 2. Okay, that is in the form of A root B. Okay, so my A is 90, B is 2, so A plus B is 92. That's the answer. Okay. Yeah, definitely this is a tough problem, especially the remembering, knowing that triangle rule actually, that OD equal to R cos theta and AH equal to 2R cos theta, or twice OD. This you should know. That is very important, and then you should get an idea that you can solve using coordinate geometry. Okay, so that is very important. Okay, so definitely hard. Yeah. Next. Okay, sorry, there is the answer already here. Okay, anyway, let's solve. Consider the collection M of all ordered pairs A comma B of positive integers A and B which satisfy. Okay, A and B are positive integers. No. Okay, they are positive integers, which means non-zero. Okay, AB equal to 406 plus 11 LCM of A comma B plus 7 times GCD of A comma B. What is the smallest possible A plus B? Smallest possible A plus B. Okay, so let's do this. Okay, so we know that LCM and GCD relation, if A, B are two numbers, A into B equal to LCM of A comma B into GCD of A comma B, right? So if you see this equation, AB equal to 406 plus 11 LCM A comma B, 7 GCD A comma B. Okay, now this term is divisible by GCD. This term also divisible by GCD. AB also divisible by GCD. So obviously 406 also should be divisible by GCD. So you already know what could be constituting the GCD. What are the factors which can come in the GCD? right? So 406 should be divisible by GCD, which means GCD should be a combination of 2 into 7 into 29, which is basically 406. It can be either one of them, two of them, or three of them. Okay, anything is possible. Okay, now you know this one. This is first clue for your GCD. Okay, now let's say for simplification, LCD equal to L, GCD equal to G. So AB equal to LG. We know it. Okay, so AB, if I replace, the equation will become LG minus 11A minus 7G. Okay, I'm adding plus 77 just to factorize easily. Okay, equal to 406 plus 77. I'm adding 77 both sides. Correct. So now the LHS side I can factorize as L minus 7 into G minus 11, and I am playing with completely integers. So this is very easy to solve this. Okay, equal to 483. 483 is 3 into 7 into 23. Now this is very simple now. Okay, how? I can find G value. Okay, G should be any of this combination, right? Okay, and G minus 11, I should get this combination here. Okay, G minus 11 equal to some number. So from that I can get G, which is this combination. So if I see here, only possibility I can see is G minus 11 should be equal to 3. Then G will be 14. 14 can come from 2 into 7. No other value is possible in this. Okay, so with simple trial and error, because we have just only three numbers to play with, right? 3 into basically maybe a combination. If you take 2 product of 2, then 6 plus all 3 1 7 individual ones plus 3 10 combinations, and easily you can find out G is nothing but 14. Okay, so G minus 11 equal to 3 is the only possible combination. Okay, so G is 14. If G is 14, I get my L easily. L minus if I substitute in this equation, I get my L. Okay, L is nothing but 168. Okay, now my product of A into B is nothing but 14 into 168, which is in this form, 7 square into 2 to the power of 4 into 3. Correct. So now I need to pick my numbers A and B such a way that their LCM is 168 and GCD is 14. That's all, right? So it is just a factorizing properly. Basically, both should have 14 in it, which is very easy to understand, right? Because 14 is GCD, correct? 14 is GCD. GCD should be part of both numbers. So if I that way, if I see more easy, A should be 11x, 14x, B should be 14y, and the product should be equal to 7 square into 2 to the power of 4 into 3. So very easily I can find out these numbers with A is equal to 42, B is equal to 56. Okay, this is the minimum. Okay, for we should find for the minimum A plus B, right? If any other number is possible, you compare which one is minimum. Okay, so A plus B, minimum value of A plus B is nothing but 98. That's the answer. Okay, this is definitely medium, because this concept is very basic for students who are practicing for Olympiad. Correct. GCD LCM is a very basic concept, which and integer number theory is very basic for students who are practicing Olympiad. So I would say this is medium, because in a 5 marks question, if you cannot solve this one, I don't think you can solve any other thing, right? So this is medium. Yeah. Next. There are 10 members in a delegation. No two of them have same height. Okay. If n is the number of ways in which they can stand in a line for a photograph such that three conditions are given. One is leftmost person is the shortest, rightmost person is the tallest, and in the line between shortest and tallest person, there is exactly one person who is shorter than both his immediate neighbors. Okay, only one such condition is allowed, where one person, the immediate neighbors are taller than him. Okay, so you have to find out number of ways, and that is represented in 100a plus b. Then what is the value of a plus b? Okay, this is the question. Now let's see how to first understand the question, then we can go and solve it. Okay, let us assume 1 to 10 are their heights, because no two of them have same heights, right? So all are different. So 1 to 10 is what I am taking in the ascending order, right? Now they will be arranged in this way. Okay, 1 is on the leftmost, 10 is on the rightmost. Okay, these two are fixed. Okay, and only variables are in between. Okay, and what is allowed is, third condition tells is, you can have, let's say, 3. Okay, and it's neighboring people, both of their heights are 4 and 5. Okay, both are taller than 3. Correct. And such condition, only one such instance is allowed, others are not in this condition. Okay, so others should be in a either ascending or descending, whatever. Okay, so Let's see. So we will assume this way. We'll solve the problem in this way. 1 and 10 are fixed. Okay. So we will give positions to other 9, other 8 people. Okay. P2, P3, P4 to P9. These are the positions where people can come and sit. Let us find out each position how many people can come, and that is your multiplication is the sum of those possibilities is your n. Correct. So let us assume this way. So for P2, what happens to P2? P2 cannot get third condition. Okay, why? Because 1 is there always left of P2, which is always less than any number. Correct. 1 is the smallest height. So shortest. So you cannot find any number at any height at P2 which will satisfy the third condition. You cannot have two neighboring taller persons because 1 is always shorter than any person, right? Okay. So P2 is only one way. So that's good. Okay. So P2 is fixed. Only 2 has to be here. There is nothing else is possible here. Okay. Now let's say P3. Okay. So in P3, let's assume that P3 position is filled by, it can be filled by any number, right? Let's assume it is filled by 2. Okay. Because 2 we are fixing on P2. Okay. Let's assume moving 2 to P3 now. What happens? Okay. If you move 2, if you place height 2, person with height 2 at P2, then P3, sorry, then P2 can have any of the other 7 persons. Correct? To satisfy the third condition, you need a taller person than 2. All 7 are taller than 2. Correct? So you can keep any, you can place any person in P2. So that means you have 7C2 possibilities. Correct? 7C1, sorry. 7C1 possibilities are there at P2. Okay? Now note down. Now P4 to P9, what happens to here? Okay? These people should be in ascending order only. Okay, if you put them in descending order, what happens? You will meet the condition 3 again and again. Okay, so other P4 to P9, everybody should be in ascending order. So that is only one way. So for position P3, okay, possibilities are 7C1. Hope you understand this one. Okay, so this is the basic, and now we will build based on this one. Okay, now let's see. For position P4, okay, so P4 can have either 2 or 3, okay, or other numbers, right? But let's see P4 equal to 2. Okay, if P4 is 2, then what happens? If P4 is 2, P2 and P3 can have any two persons because you choose whatever way you choose, both will be taller than P4. Okay, so you can have either 3 4 or 4 3, or you can have 7 8 8 7, anything. Okay, but whatever two persons you are taking, you can also place them in two ways. That is important. Okay, you can either place them in 3 4 way or 4 3 way. Okay, so you will get whatever two people you choose in 72 ways, you can choose the two people. These two people also can be arranged in 2 to the power of 1 ways. Okay, 2 into 1 basically, right? 2 into 1, so 2 to the power of 1. So P5 to P9, the other all others will be placed in P5 to P9 in ascending order. That's only one way, and people can be placed at P2 and P3 in 2 factorial ways basically. 2 into 2 into 1 ways basically. Okay, that is 2 factorial, you can say. Okay, so now the number of possibilities at P4 are 7C2 7C2 into 2 to the power of 1. Okay, this is for P4 if height of 2 person with height of 2 is placed here. Now P4 you can also have height of 3. Person with height of 3 also is possible. So for that condition, what happens in this condition? Okay, if I place 3 in P4, okay, I cannot keep 2 here. If I keep 2 here, third condition is not met. Okay, height 2 is less than height 3. Correct? This is not possible. So only possibility is other 6 people. Okay, P4, P5, P6 or 4, 5, 6, 7, 8, 9. Other 6 people can come here. That is 6C1 ways only they can come here. And 2 has to be here. There is no other way. Okay. So this is for position 4. If you keep a person with height 3, then 61 ways are possible. Okay. So now total number of ways at position 4 is 7C2 into 2 to the power of 1 plus 61. Okay. So this is for position 4. Okay, now we will just extend this one for one more position and see if there is a pattern coming. Okay, right. So for position 5, Position 5 can have 2, 3, 4. All three are possible. So position 5 will be equal to 2. If you take 2, these are the possibilities, correct? I can have any 3 in P2, P3, P4, correct? That is 7C3 ways. So, and I can place them in this way, okay? I can place them in uh, 3, 4, 5, 3, 5, 4, 4, 5, 3 and 5, 4, 3. All these ways I can place them here, correct? So that is 2 into 2, which is 2 to the power of 2 ways, okay? So P2, P3 and P4 can be placed in 2 to the power of 2 ways, okay? Now possibilities for position 5 with height 2 is 7C3 into 2 square, okay? And position 5 with 3 is, if I keep 3 here, okay, 2 has to be fixed. 2 cannot come, then 2 cannot come in this position, right? 2 can come only here. If you keep 2 here also, then also you will get one more condition 3 here, right? If 2 is here, one more condition 3 will get. So this has to be fixed position only. There is no other way, correct? Right? So 2 is here fixed, and 7 and 9 can interchange basically. Okay, so these two can be placed in 2C 6C2 ways, correct? Position 5, P2, P3 and P4 can have any of the 6C2 ways. Any 2 can be placed out of the 6 people, correct? So 6 2 ways. Now P3 and P4 can be arranged in again 2 factorial ways, correct? So now possibilities are 6C2 into 2 to the power of 1. Okay, so now position 5 is 4. Okay, in this case 2 and 3 has to be fixed. Okay, you cannot have 2 and 3 at P3. Okay, sorry, P4 you cannot have 2 and 3. Then the third condition will again meet actually. So here 2 and 3 has to be fixed here and no order change, because if you change the order also, the 2 will meet the condition 3 again. Okay, so this one, and the remaining 5 out of 5, 5C1 ways I can place here one position. So 5C1 ways, that is 5 ways. Okay, so my total number of possibilities for P4 are 7C3 into 2 square plus 6C2 into 2 to the power of 1 plus 5C1 into 2 to the power of 0, which is 1. Okay, so now if you see the pattern here, this is very interesting. Now you can see the pattern emerging like this. P2 has 7C1 into 2 to the power of 0. P3 has 7C2 into 2 to the power of 1 plus 6C1 into 2 to the power of 0. P4 has 7C3 into 2 square plus 6C2 into 2 plus 5C1 into 1. Right? So now this is the pattern, it will continue. So you write it for all the positions P5, P6, P7, P8 in the same way, and you calculate the sum. So n is nothing but 1636, and this is in the form of 1600 plus 36, that is 100A plus B. Then A is 16, B is 36, correct? So A plus B is 52. That is the answer. Yeah, so problem looks easy when you hear the explanation and how the pattern is emerging, but you should believe that there is a pattern coming and how to find each position. This is definitely tricky and hard. So definitely I would say this is very hard. Okay, yeah, next. Let ABC be an isosceles triangle with sides 13, 13 and 10. The tangents to the incircle drawn parallel to the sides intersect the sides in point D, E, F, G, H, K, which form a hexagon. If the area of the hexagon D, E, F, G, H, K is m plus n by L, okay, where they are positive integers and in the minimal form basically, what is the m plus n plus L? Okay, first thing we need to find out is area of this hexagon. Okay, so first let's draw the picture. So this is the ABC triangle and this is the incircle, and you have a parallel lines. DE is parallel to BC, FG is parallel to AC, HK is parallel to AB. Okay, now this forms a hexagon D, E, K, H, G, F. Okay, the order given here is not correct. We are assuming that they meant to say this hexagon. Okay, so this hexagon area we need to. So one thing is this hexagon area is nothing but area of ABC minus the small triangles, right? ADE, CHK and BGF. Okay, if you subtract this, find out these three areas and subtract from ABC, then we'll get the hexagon area, correct? So let's see how to do that. Let's first thing is, yeah, understand that this is how I can get the hexagon area. Okay, and then draw a perpendicular from ABC onto opposite sides. Okay, so these are the perpendiculars. Okay, okay, so if this is perpendicular, okay, If this is perpendicular, let's take a case of AX. Okay, how to find AX? If AX is perpendicular, then this is 13, correct? AC is 13, this is XC is 5, so I can get AX. 13 square minus 5 square, which is 12 square, so square root of that is 12. So AX is 12. Now we got AX. Okay, so area of the triangle is half into 12 into 10, which is 60. Now you got triangle ABC, area of triangle ABC. Okay, now BY and CZ also equal to, you can easily find out, right? You have the AC, which is base, and these are the heights, and the BY and AC will be, BY and CZ will be same because it's an isosceles triangle. So that is 2 times area of the triangle by AC. Okay, so which is nothing but 120 by 13. This is the BY and CZ. So now you have BY and CZ values also. Now what you need is AP value, CR value, BQ value. Once you get that, you know that these are similar triangles. ADE is similar to ABC. Okay, they are the similar triangles. So the areas will be in the ratio of squares of their sides or squares of their altitude. Correct? So let's find out AP. Then we got the answer, right? We got the area of ADE. Okay. So now radius of the incircle is, we can find the radius because if you see here, AP is nothing but AX minus 2R. Correct? AX minus 2R is AP. So R is nothing but area of the triangle by semi perimeter. So that is 10 by 3. This is my incircle radius. So now my AP is AX minus 2R, which is 16 by 3. BQ is BY minus 2R, which is 100 by 39. CR is CZ minus 2R, which is 100 by 39. Again, same, right? We know that BQ and CR will be same because BY and CZ also same, and we are just subtracting minus 2R. Okay, now you have all the required information here. Now, triangle ABC is similar to triangle ADE, which means their areas are in the ratio triangle ADE and triangle ABC areas are in the ratio of AP by AX whole square. Okay, so from that I can get my ADE area, which is nothing but 60 into, okay, 16 into 16 divided by 3 into 3 into 12 into 12, which is 320 by 27. This is my area of ADE. Similarly, I can find my BCA. Similarly, I can find my BGF. Okay, this is my BGF, and then CHK. CHK is this one. These 3 areas I found. Okay, so note down that these 2 areas, BGF and CHK, will be equal because of isosceles property. Now you have all the information what you want. So the hexagon area is nothing but, if you calculate, you will get 350 by 9. Okay, so 350 by 9, I can write it in 38 plus 8 by 9, which is my m plus n by l. So my m plus n plus l is nothing but 55. This is the answer. Okay, yeah, hope you, I think this is relatively easy compared to other questions here actually. Okay, but still definitely hard. You need to get that idea of deriving altitudes and then similar triangles concept, and then yeah, lots of things are there. Okay, and you should not go wrong in the calculation, right? So yeah, this is the one. Next, the vertices of a regular dodecagon, which is polygon with 12 sides, are colored either blue or red. Let n is the number of all possible colorings such that no 3 points of the same color from vertices of an equilateral triangle and no 4 points of the same color form the vertices of a square, which means square either points, nodes which we form a square cannot have same color. Nodes which form a equilateral triangle also cannot have a same color. Okay, find out that n in the form of some 100 p plus q. Then what is the p plus q? Okay, let's understand this problem. So this is the problem I was talking, the toughest problem in this paper, and probably toughest in one of the IOQM questions itself. Okay, history of IOQM. So yeah, really, if you have attempted this question and correctly solve it, then definitely you are a math genius. Okay, you will be definitely seeing sitting in the Indian team mathematics Olympiad. Okay, so let's break down the problem and understand this. So these kind of problems are definitely part of your RMO if you are going into next level, right? Then you need to understand how to break down the problem and solve it. Okay, so first thing is a dodecagon. Okay, that is 12 notes like this. If you imagine like a clock, then you have 1 to 12, right? It can have 4 equilateral triangles and 3 squares possible. How? See, look at this blue triangle. Okay. And this I can rotate it 1, 2, 3. Right? Already it is 1. So 2, 3, 4 I can rotate. If once it's rotated to 5, it is same as first position. Right? And square is formed with these points 1, 4, 7, 10, and you can rotate it is 2 times. So you will form 3 squares. Okay. And what are the nodes possible? Triangle nodes are 1, 5, 9 if you see, and rotate it. So you will get 2, 6, 10, 3, 7, 11, and 4, 8, 12. Similarly, square nodes are 1, 4, 7, 10. Rotate, then you get 2, 5, 8, 11, and 3, 6, 9, 12. Okay. So once you have this basic understanding of how this dodecagon is placed, okay, and how the equilateral triangle and squares are formed, okay. Now let's get into the problem. Each node of the triangle group is part of one thing you understand. Okay, if you take triangle group, let's take this 1, 5, 9. Okay, 1, 5, 9. So 1 is part of this square, 5 is part of this one, 9 is part of this one. All different. 2, 6, 10, same. 2 is here, okay, 6 is here, 10 is here. Okay. So similarly, you take a square, then they are part of 4 different triangles. 1, 4, 7, 10, right? 1, 4, 7, 10. Okay. So this is one property which you need to understand. Okay. Now next up. One square node can be colored in one node can be colored in two ways, right? Two colors. So one square has 4 nodes, so 2 into 2 into 2 into 2, which is 2 to the power of ways, we can color them. Okay, but it cannot have all red, it cannot have all blue. Correct? So you subtract 2 to the power of 4 minus 2. Correct? So which is 14. 14 ways you can color a node in a square. Correct? And how many squares are there? 3 squares can be formed. So 14 into 14 into 14, which is 14 cube, is the possible colorings of all squares. Okay. Now this may match with your, this may contradict your condition on triangle. Okay. But this is the possibility of coloring a square. Okay. Similarly, one triangle node can be colored in 2 into 2 into 2 ways, because 3 nodes are possible in a triangle. So each node can have any of the 2 colors. So 2 to the power of 3 ways. But out of that, all red, all blue we have to remove. Okay. So 2 to the power of 3 minus 2, which is 8 minus 2, 6 colors are possible for each triangle. Okay. And how many triangles? 4 triangles. So total possible colorings for triangles is 6 to the power of 4. So out of these two, definitely 6 to the power of 4 is smaller number compared to 14 cube. So we will start with we'll take the all possible colorings of triangle, then subtract the colors where it forms a square with all same color. Okay. So this is the way we should proceed. Okay. So now what is the theory behind this one? We will solve this problem, okay, using the principle of inclusion and exclusion. So what is this one? We have seen, actually we know this already. Only thing is we don't know that this is the name. Okay, if you see the set theory, A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, right? So this is principle of inclusion and then exclusion of common things. All right. If you go to A union B union C, you will understand very easily. A union B union C equal to A plus B plus C, correct? Number of sum of number of elements in each set minus A intersection B minus B intersection C minus C intersection A. Then we say plus A intersection B intersection C. Okay. The next level, each level comes with a different sign basically. First time you will have inclusion, then you have exclusion, you subtract it, then you have a inclusion. Next level you will add the terms, then next level you will subtract the terms. Okay. So this is the principle we use to solve this problem. Okay. So how to do this now? Okay. Case 1, at least one square. Now you have number of possible colorings for all triangles, which is 1296. Okay. Now we will first exclude at least minimum, at least one square has same color. At least one square has same color. Okay. So how many ways you can select one square? 3C1, there are 3 squares. So 3C1 ways I can select the square. And the number of ways to select color, 2 ways. Either it can be red or it can be blue, right? So let's say 1471 is all red. Okay. Let's say 14710 is all red. Okay. If this is all red, go to triangle tuples. Okay. If one is red, 5 and 9 can have any of the 2 colors. Correct. So 2 into 2, 4 colors, but it cannot have same color as same red color, right? So minus 1, I am subtracting minus 1. So 5 and 9 can have 3 colors. Okay, so number of ways this triangle can be colored is 3 ways, correct, which is RBB, RRB and RBR. Correct, 159 can be colored these 3 ways. Similarly, each triangle can be colored in 3 into 3 into 3 into 3, correct, 3 to the power of 4 ways, right? Now total possibilities of this case is 3C1 into 2 into 3 to the power of 4, which is 486. Now we will exclude this from the 1296. Okay, now next. So this case includes not only one square is same color, but it is at least one square is same color. Okay, understand that. So it is possible that if you subtract this, is this the answer? No, because you can have at least 2 squares also colored, 3 squares also have same color in this, still included. So those things also we should consider, subtract or add based on this principle of inclusion and exclusion. So next level we'll go case 2. Okay, so these are my triangle and square nodes. At least 2 squares of same color now. Okay, so how many ways you can select 2 squares? 3C2 ways. Okay, out of 3. Now first case. Okay, 1 4 7 10 again, and 2 5 8 11 both are red. Okay, how many ways I can select colors? That is also 2 ways. Okay, so let's, when we compute it for the subtotal, we will get it. Okay, now you go to the tuples. 1 4 7 10 and 2 5 8 11 are red. Okay, so 1 and 2 are, in this case you have 1 and 5. 1 and 5 both are red. So how many ways you can color 9 now? Blue. That's the only one way. You have to color it in differently now, because 2 of the squares are same color. Correct? So node 1 and node 5 are red. So node 9 can be colored only in one color, right? That is blue. So which means 159 only option is RRB. So each triangle can have only one way of coloring. Okay, so all triangles 1 power 4. That's the only possibility. Correct? Now second way is, if these two colors are not same but different. Okay, now I will, if I multiply with the 2, I'll get for blue also, right? If both are blue also, same case. Okay, now sub case 2b, if 1479 is red and 25811 is blue. Okay, now what happens? This already has one red, one blue. Triangle has already one red, one blue. So third node can be anything. It can have two colors. Correct? Node 9 can have two colors. So triangle has two possibilities. 4 triangles will have 2 to the power of 4 possibilities. Correct? So subtotal here is 3C2 into 2, because it can have, I calculated only for red, but blue also this is same. I calculated for red and blue, but it can be blue and red also. Correct? So 2 times 1 plus 2 to the power of 4, that is 3 into 2 into 17, which is 102. This I will add, because last time I subtracted, this case 2 I will add. Okay, now next case 3. Here at least 3 squares are same color. Okay, first thing is, understand, 3 squares same color does not mean that all 3 squares are red or all 3 squares are blue. That we already removed that condition. Correct? This means, okay, square 1 is red, square 2 is red, square 3 is blue. Or square 1 is blue, square 2 is blue, square 3 is red. Okay, each square has same color nodes, but all squares are not same color. Okay, that you have to understand. That case we are considering. Ways to select 3 squares is only one way you can select. Okay, and number of ways to select colors is 2 to the power of 3 minus 2, because all cannot be red, all cannot be blue. Correct? So this condition we are removing. So 6 ways. Now if 2 squares are red, 1 is blue, what happens? Then triangle, already it is matching in triangle tuples. Node 1 and node 5 are red, and node 9 can have one color, right? Same blue, it is already blue. So that is anyway done, right? So possible ways of coloring is only 6 possible ways I can color, right? So this is my case 3. Now most of the people might be missing this case 3. This is the where you may go wrong actually in this problem. Now, next, we have all the information required now. Okay, possible colorings for all triangles is 1296. At least one square has same color, 486. At least two squares have same color, 102. At least three squares have same color, 6. Now using principle of inclusion and exclusion, we can say number of possible colorings are 1296 minus 486 plus 102 minus 6, which is 906. Okay, so 906 is written in the form of 100p plus q, which means p is 9, q is 6. So 9 plus 6 is 15. That is the answer. Okay. Hope you understand this problem. How to solve it, at least approach you should know for future learnings actually. This is really the toughest problem in IOQM so far. Last paper also, it's same 2025 also. 30th question is really tough. I think it is very clear that they are giving a hint that okay, they want to identify the students who solve this problem and go to next level basically. Okay. So I think this is definitely hard. I would say more hearts I can put. Okay. So these are the all the questions of IVQM 2025 region 4 and 5. So with this we have solved all the sorry, this is done actually. No next video. Okay. So we have done all the IOQM papers for 2025. I will keep adding more practice problems. Keep checking my channel. Thank you.